This project is sponsored by PCBWay. From July 1st to July 31st, 2026, PCBWay is organizing 12th anniversary campaign. Grab your discount and unlock more rewards in the form of exclusive coupons, PCB orders for just $5, Trunky electronic design services, up to 50% off for 3D printing and CNC machining, and special sales in PCBWay store. Join the fun with interactive games and receive your exclusive engineer color personality. Click the box to participate in the lucky draw, show your colorful projects and vote for the most popular badge. Order now and get big discounts. Hello, color detection is a fundamental task in many embedded systems, from industrial sorting machines to smart home lighting and do-it-yourself electronics. When using a microcontroller like the ESP32, there are two common approaches. First, camera-based detection, and second, optical sensors with integrated color filters. The first system uses a camera module to capture an image, then the MCU or a connected computer runs algorithms. This way consumes much more processing power, memory and energy. Optical sensors, on the other side, contain photodiodes with green, red, blue and clear filters, plus an analog to digital converter. The MCU reads the intensity of each channel via I2C protocol. This method is fast, low power and works well, and no complex imaging processing is required. The project presented in this video uses a second, more efficient approach, using a dedicated color sensor to achieve real-time accurate readings with minimal resources. The hardware implemented in this project is ESP32-C3, a compact Wi-Fi enabled RISC-V chip. This small MCU board handles sensor reading, PWM generation for the RGB LED and runs a web server. Next, color sensor board TC34725, which should be close to the target object to exclude ambient light. The sensor has a built-in white LED to illuminate the sample. Next, a common cathode RGB LED connected to 3 PWM pins. This LED mirrors the detected color, providing immediate visual feedback, and smartphone connected to Wi-Fi access point created by ESP32-C3 microcontroller unit. The components are mounted in a suitable housing, and the sensor is protected from external light influence. As for the code, it consists of two parts: small calibration code and functional code. The calibration code is used in a way that a white paper is placed in front of the sensor and the values for RG and B are recorded on the serial monitor. Then these values are placed in the main code at the beginning, where the constants are defined. The main code has a part for controlling the sensor and the local RGB LED, as well as generating a web interface for displaying the results on a smartphone. Now let's see how the device works in real conditions. By turning on the device, the white LED inside the sensor is activated, whose function is to illuminate the object in order to read its color. The detected color is immediately displayed on the RGB LED placed close to the sensor. Green, red, and blue. In reality, the colors are displayed quite correctly, but in order for this to be noticeable on the camera, I had to reduce the ambient light. This device also has the option to display the result on a smartphone. For this purpose, we need to connect the smartphone to the Wi-Fi network with the name ESP32 Color Detector. ESP32 Color, and the password is 12345678. Okay, we are now connected. Now we need to enter the address of the access point generated by ESP32 in a web browser, which is 192.168.4.1. Here a graphical interface opens where we can see the read color as well as the individual values of the red, green and blue colors. On the lower half of the display we also have a graphical display of these values and the representation in terms of wavelength. Let's try. And finally a short conclusion. This is efficient ESP32-C3 color detector utilizes a dedicated TCS34725 optical sensor to provide fast, real-time and accurate color readings without demanding heavy processing power. With its instant local RGB LED feedback and an interactive smartphone web interface, the project serves as a highly practical and low-power solution for embedded color detection. And finally a short conclusion. This efficient ESP32-C3 color detector utilizes a dedicated TCS34725 optical sensor to provide fast, real-time and accurate color readings without demanding heavy processing power. With this instant local RGB LED feedback and interactive smartphone web interface, the project serves as a highly practical and low-power solution for embedded color detection.